Hi, and welcome to this new video about kernel memory, where I'm going to show you how you can make your C# code interact with Python code to create a solution where you do not use anything in the cloud for RAG. You will only use local model. And so without further ado, let's dive into the solution. First of all, you need to customize the embedding part. And this is because if you cannot call any model from the cloud, like Cohere or ADA or the new embedding model by OpenAI, you need to use one of the models that Hugging Face gives you. There are tons of embeddings included in Hugging Face, but the problem is they are really, really easy to use in Python and a little bit complex to use in C#. So how is the best way for having the best of the two worlds so I can easily use in Python a model from Hugging Face and I can integrate it in kernel memory? Let's see how you can obtain this with very, very few lines of code. First of all, I want this solution to be fast. So what I want to do is creating a server with Python that can expose an API, which HTTP standard REST protocol, to allow my kernel memory code to call model from Hugging Face that can be easily used in Python. And the first thing you need to do is this model are not safe for multi-threading because they are using Torch. So you cannot use the same model with more than one thread. So if you expose a model with a fast API, you need to be sure that different code will not reuse the same model in the same thread. So I created a simple pool that can create more instances. It's max size. I'm allow a certain number of parallelism, and this depends from the memory on your GPU, the memory on your system, because each one of instance of the model will consume memory from your GPU and standard memory from your system. So I'm simply creating a pool of max size transformer. And as you can see, creating a sentence transformer that basically is a component in Python from Hugging Face that can generate embedding from text is as simple as creating the sentence transformer with the name of the model. So I pre-create a certain number of this model, and then when the code use get, I simply take some time, some statistic, but the idea is I want to self-pool get from my self-pool is as queue. This queue object in Python allows for safe for multi-threading, handling of a certain number of instances in a queue. So with the get, I'm getting one of the instances from the queue, and with the release, I'm releasing and I put again the transformer, the model inside the queue. So the idea is the fast API, for each call, it will try to get one element from the pool. It will wait for an element to be available. And then when it finished using the model, it will return to the pool so it can be used by another thread. And this allows me to easily synchronize thread call between models, between various API calls. Then I'm simply creating a fast API Python server to expose functionalities on REST endpoint. I'm creating some class for the DTO parameter that I will use for calling. And I chose a default model for my solution. And then I have standard utility load model and release model. And then I have, with this syntax from fast API, I'm defining the endpoints that will be called. And finally, after I define all of my endpoint, I simply create an argument parser if you want to run on a different port than the default one. And then I use the UVcorn to run this on all the EP of this machine. So actually, when you launch this example, you will have a series of model preloaded inside a cache, and then it starts waiting for you to call the model. To verify that the model works, you can use tools like Postman to simply call the server. So now I'm calling the dimension, not passing any argument. So I want the dimension of the default model. And it tells me that the model OLMPNet base v2 has a couple of important dimensions. The dimension is the number of dimensions that the output vector is. And it's important because when you configure your vector engine, you need to specify how many dimensions your vector has. But another very important parameter is the max sequence length that tells you how much token is the maximum allowed number of token for generate a sentence embedding. And the result is if you pass a sentence that exceeds this number of token, the SBERT model simply will truncate everything. And so you will have a embedding generated, but it will include only the first part of your sentence. So this is an important parameter because when you configure your RAG application, when you configure kernel memory, you need to be sure that it generates no segment greater than the max sequence length allowed by the model. So it's a really important element. Then you can have, you can test a count token endpoint in which you send a sentence and it will give you back the number of token. And this is also important because each model can have a different tokenizer. So you cannot assume you can use the tick token library using the standard tokenizer of GPT, for example. So to be complete solution, to be a correct solution, you need to give the user an endpoint that allows you to send a sentence and ask to the model how long it's in token. And finally, you have the process sentences where you really gives an array of sentences to be converted, and it will respond with an array of vector where each element of the array is another array, is the vector representing the embedding. And it will return always the model parameter telling you which is the parameter that was used to generate the embedding. And this concludes the setup. So it's very, very simple. So the simplest solution to integrate some model from Hugging Face into your kernel memory or C# code is simply exposing functionalities through Fast API. It is simple. It can allow you to call your Python code simply using REST API, which with a standard HTTP client. And this is the way you can really make two words collaborate together, where you can use Python for the part where Python shine, like using Hugging Face model, and you can still use C# for everything else because it's your language of choice for your architecture and your software. Now, since my example uses sentence BERT, SBERT, I've simply called this example BERT. So if I launch the BERT, it asks me if I want to use a local model, and we will see how we can interact with the local model. And the idea is, for now, I simply specify no, and it start indexing my document. And as you can see, I've dumped all the time I'm calling my Fast API server. So as you can see, I've done thousands of call, especially in count token, and 45 call to the embedding in very few seconds. So the Fast API allow me to call Python code from C# using REST protocol in a really, really super fast way. And let's see how I make this happen in kernel memory. The key is creating a simple external embedding generator class that implement the iText embedding generator. And I'm simply using a constructor that will accept the HTTP client factory and the embedding generator config. So we can simply use the HTTP client factory to actually create an HTTP client to make the HTTP call. And the embedding generator config will contain some config, like, for example, the name of the model I want to use. So it is completely flexible. I don't need to recompile anything if I simply want to change the name of the BERT model I want to use. Now, when you construct the instance of your custom sentence embedding generator, I call the scan model function. The scan model function method is really simple. It creates an HTTP client, and this code could be refactored to have a standard way of calling the API. You can use whatever library you want to ref it or other library to simplify calling the API. This is the most low-level code, but it shows you how easy it is. I simply specify the URL, and this is the dimension URL, and I generate a body, the DTO I'm sending. I use a string content using the JSON serialize the body, and then I verify that the code answering correctly, that the API answer with such a status code. Then I simply read everything as a stream async and pass to the deserializing with the dimension result. And so this allows me to initialize my embedding, creating two internal property that will be used by kernel memory that tells how much it's the vector size for this model and how much max token are in its max sequence length. That allow me to simply ask directly the Python REST API, hey, I want to use this model, give me the number I need to use for this model. And so I see you have these two property. I initialize with standard dimension for my default model because that's the configuration, and the configuration is simple. I simply need the model name, the default model name, and color can override this, and the address that is standard port 8000, but the color can override. And then it's not a mystery that all the other methods are all almost the same. So the count tokens method will simply use same a client, an HTTP client that allow to call me the other endpoint, the count tokens, and same code as before. Check the result of the API and return the value. And the generate embedding async is the very same. It's simply called the process sentences. It's simply blah, 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 and then return the information. So basically, I've made this extremely simple because the code that interact with the model is all written in Python, and I have only the code in C#. It's a simple code that call REST API, and it can be parametric, and all the complexity integrating with the model is in the Python part of the software. So I made the two-word dialogate fast with REST, simple REST API you can debug, and it's probably the best way of using the language most that for you is the most useful for each purpose. If you're using kernel memory, you are writing code in .NET, so you write most of the code in .NET because it's your familiar language, and then you use a very small part of the Python code for the only part that you need to simply interacting with the model from Hugging Face. Now, you can use local embedding, but for the G part of the RAG, you need to interact with a large language model because the G part of the RAG acronym is generative. It's the retrieval augmented generation. So you need a large language model that takes as input the question of the user, the fact that you extract from your memory, and ask to a large language model to answer. So for this to happen, you need to have a way to run a large language model locally for testing. And then when you go in production, you probably use Amazon Bedrock, Azure AI Studio for creating a solid structure where you can make an open source language run. If you cannot go to the cloud, everything should be on premise. You will just need to buy capable software or capable hardware for running this model. To experiment, you can use LMStudio. It's a super cool software that allow you to search easily for model in Hugging Face and can run the model in a quantized version in your CPU using GPU. And in this situation, I'm trying to use Mistral extract for 5Q5. It's a number that tells me how quantized the model is. The short, the smaller is the number, the more quantization is aggressive. Model run faster, but it's usually less smart. And you need to experiment. Thanks to LMStudio, I can offload some of my part of the model on my GPU. I have a 3070. And I can press a button to expose a server where you can interact with the server using a simple call that follow the very same schema of OpenAI. So you can tell to your configuration that you are using an OpenAI server. Simply, you need to just change the URL pointing to a localhost. It's port 1234, but it's you can customize it. But this is only for testing. But this allows you to test a local large language model for creating an entire pipeline in kernel memory that use local model for embedding and local model for generation. Now let's execute again. The example is the example number 3. So I want to use a local model. As you see before, I'm calling the local fast API in Python for generate embedding. As you can see, it's very, very quick. It's really fast. And then it is asking me, ask a question to the kernel memory or write who or quit to exit. So I've indexed a small document and I can perform a question like, please explain the black sheep concept. And I'm trying to do this. And when I press enter, I can go to my LMStudio, and as you can see, it is generating my answer. As you can see, it's pretty quick for running on a local machine, but I need to give you a warning. When the large language model is generating tokens with LMStudio, usually it will use all the resource of your computer. So you can execute only one inference at a time. And even if the generation is quite easy, because it generates a lot of token in very few seconds, it will not scale for production use. And this is important because you need to understand that to go in production, you need a different strategy. But nevertheless, it allows you to run the whole example locally. So I have my answer, the black sheep method is cosmel that refer blah, blah, blah. So this is fantastic because now I've run with kernel memory an entire RAG pipeline only with local text and only with local resources. Nothing go to the cloud. Nothing uses an external API. For completeness, I explain the code with LMStudio text generation. It's the text generation is the kind of class, the iText generator that create the G part of RAG pipeline. Remember that the G part in RAG, it means generation, and it needs a large language model to take question and fact and generate the answer. So it is necessarily a generative AI that need to conclude this part, the RAG pipeline. So the iText generator is a simple interface. This is a simple and stupid example. I probably will need to I probably need to create a configuration because in this scenario, I've hard-coded the max number of tokens that my large language model can accept. And this clearly is depends on the model you are using. And so needs to be parameterized, but it's not the problem. And okay, and as you can see, when the kernel memory create the generate text async, the same piece of code happens. I use the HTTP client factory for creating a client. I create a body using the standard structure for OpenAI, create my request message, send the post, and then check the result of the API, and finally yield the return to the caller. And for each completion choice, this is the very same model of the OpenAI. So for each choices, it'll return a content. So this is how simple it is to integrate another external large language model if you expose this model with an REST API that is similar to OpenAI. And this is done by LMStudio, but if you need to write Python code, it's simple. You can always use the Fast API and a schema that is compatible with OpenAI or your custom schema. The important thing is from the C# view, all these services are simple REST endpoint, like real API of OpenAI. And clearly, this is the configuration. So if you want to use your local large language model, instead of specifying with Azure OpenAI text generator or with OpenAI text generator, you will specify with custom text generator. Remember, text generator is the G in RAG, is the part where you interact with a large language model to give the answer based on question and fact. And as you can see, you can simply create an instance and specify parameter. If you prefer, you can create a configuration object and inject with inversion of control. It's the very, very same. Then for custom embedding, you use the function with custom embedding generator. And even in this situation, you can simply specify a new instance of external embedding generation, and in which you can specify with the external embedding generator config the model you want to use. It's very, very, very simple. So there's nothing complex. Finally, I want to show you how I can customize the default custom text partitioning, the text partitioning component. And this is the component of kernel memory that takes the whole text of the document and creates segment to be indexed in vector memory. You can use the very same class without any need to replace with your class, but you can specify the option. And in this situation, I want to be super, super sure that the max token per paragraph is 384 because I'm going to use a model all MPNet that has this maximum length in tokens. So I want to be super sure that I'm not creating paragraph exceeding this value, because all exceeding value will be truncated and my embedding will not have a good performance. Okay. And you can choose other option, but this is the one I care the most, because I want to be super sure that I'm not exceeding the length of the model. And this concludes this video, where I show you how simple it is to configure and to extend kernel memory to use a complete RAG pipeline based on local resources. And then I strongly suggest you that you start using online resources, because embedding of OpenAI and other is really, really the best. GPT-3 is really, really good. And then if you are really, really constrained to use local resources, you need to do a sort of experiment and test, because not all embedding are the same, not all local large language model are the same. So you need to be prepared to create a standard test suite where you can evaluate which model is best, which parameter are best. And so it's a longer process. But thanks to kernel memory, you can do this in a very simple way. And this concludes this video. Bye-bye and see you on the next one.